two basically bias. One is called forward bias, another one is called reverse bias, right? So let's see, this is yeah, false state, right? So here you can see this is a diode, okay, and we have connected here AC source. Okay, what is the value? We can double click and check it here. The maximum voltage is showing here, minimum voltage is showing here, frequency is shown here. So when it is operating, you see, so how it is working, this VI characteristic like that. Okay, in order to understand this, you look here. So we applied here triangular wave. See, this is the triangular wave. Okay, so how it is happening? See, the voltage going down, and this is the dot corresponding to the voltage, how the voltage is increasing. So you can see that voltage is increasing, but current there, no current there. But as it reached to the this point, and this point is how much is the voltage at that time? 0.7. You can see this is in millivolt, 72163 millivolt, yani 0.7 volts. So as it reach here, the quickly current quickly pass through this diode. You can see now, and again because it's a triangular periodic wave, so now it is going back. So maximum value is here, and what is the maximum value? I can see it is 8. Now going down, now increasing like that. So it is about the VI characteristic. Also, I can show you another some of the graphs, circuits. You look here, this is the diode connected in a circuit, series circuit. All right, and we have connected here a voltage source of 5 volt, and this is a diode, and this is a basically 1 kilo ohm resistance. So you can see, because this is a DC source, so definitely its value is fixed. We know that the DC voltage is always fixed, it's not changed. So 5 volt is always connected here. And what so just a minute, I will show you this way. So 5 volt is connected to the anode, you know that one, this is called anode. And what is the another terminal? What is the name of another terminal? Is anode, and this one cathode, right? So how it is connected? So you can see positive battery connected with this one, and negative, and here is connected the negative one. So it means the diode is always in forward bias. You can see the current is flowing in the circuit. All right. So now we can also see, rather than this DC, if we connect the AC. See, here is AC, and what is the property of AC? AC goes maximum, then it comes down, right? We know this one, right? And again increase, again decrease. So what happened? When it reach above the 0.7, so diode will conduct, yani diode will be on. We can say diode will on. And when the voltage comes, below 0.7 or 0 here, but diode will be off. We can see this is gonna be at that time off. So now see this circuit, how it is operating. So here, when negative is coming, it's off. So just a minute, I'll show you the waveforms also. When we right click here, we can say here scope. So this is the voltage waveform, correct? Okay, now we can also see the voltage across. We can plot here. Existing. All right, now see. So you can see when the this one is above, this one 0 and 0.8 above, so then only diode is conducting, otherwise diode is off. So you can see the down, so the diode is not working. Even it will become red. You can see when it is red, it means it is in reverse bias. Now reverse bias, now forward bias. So reverse, forward, reverse bias, alternation is there. Okay, this is for understanding. Now for the DC, I can show you some more concept. Like in here we are connecting 5 volt. You can see when I double click, its value is 5 volt. Let's do one thing. Rather than having once only try to have more than one. So if we have more than one, just stop this simulation and I don't know, okay, remove it, cut it, and just put here somewhere, and one more battery. I am saying one more battery, huh? So bring this battery here, drag and select. So now we have two batteries, and this is the resistance connected now. So what do you think? This is 5 volt, we know that, and this is also 5 volt. Both are 5 volt, 5 volt. So when I simulate this circuit, will this gonna be in forward bias or reverse bias? What do you think? Diode will be in forward bias or reverse bias. When I see, turn it on, you can see this one.
Maybe forward.
This is 5 volt. This is 5 volt. This is also 5 volt. Both are 5 volt, 5 volt. So should it be in forward bias, or how it will be in forward bias? What is the rule? Yesterday I told you that anode should have 0.7 greater voltage at least, then it will be in forward bias. Do you remember? Did I tell these things yesterday, class? Concept of anode and cathode and how it should be relation there. So if both are 5 both sides, so how it will be? So this is in reverse bias. Okay, we can see also, just remove the plot. Okay, so it is in and you can see there is no current flowing. If current will flow, you know that how it will flow. It will be showing you like in this circuit it's moving. But see, if I make, for example, let's change it. I'm making it how much? 4 volts. Okay, let's check now. So forward bias, you can see this one now. Correct? Okay. So now just do one thing. If I remove this one and just connect a wire here, add wire, so it is forward bias, right? Now if I reverse the polarity, see, it's in reverse bias because it is now negative is connected here and positive is connected here. So what does it mean? It means is that this terminal is more negative. This terminal should be more positive with respect to this terminal. Then only it will be in forward bias. Getting the point? So this time it is in basically reverse bias. All right. Now, so when it is in reverse bias, girls, yeah.
Can you repeat the last thing you said?
What I said this terminal, yani anode, must be more positive with respect to the cathode than will be in forward bias. But here you can say you can see here the negative is here. Yani anode is negative, and if you look here, cathode is positive, right? So
yes.
If anode is negative, how it could be in forward bias? So it is in reverse bias now. So no current is flowing this time. You can see no current here. There's a stop here. Correct? This is the concept. Now if I just make reverse the polarity, forward bias, because anode is more positive with respect to cathode. So it is in forward bias. Okay, girls. Now coming to the another concept. Do you remember the this practical model? Practical model consider that this diode will not only be in forward bias, will not behave like a switch, but it will also consume 0.7 volt across it. Then only it will be in forward bias. So if I ask you how much will be the voltage across this resistance, so what should be your reply? Voltage across 1 kilo ohm resistance. How I will calculate this? Have you forget? Yesterday I told you the formula. For example, if we are saying here is V1 voltage, okay, it's flowing this one positive negative. So we can say now V1 is equal to applied voltage. How much? Vs minus VB, barrier potential, over resistance. So how much you are applying? Source voltage. How much is the source voltage? 5. How much will be the barrier potential?
0.7.
0.7 over
1 kilo.
1 kilo. So how much will be the answer? 4.3 what? Milli. Very good. Millivolt, right? This is, it should be correct. So can we check this one also? Okay, in order to check this one, what I can do, I can connect a voltmeter across this resistance, and it will also give me that one, correct? So let's try this one. So I can have a voltmeter, go to output, and in the output we can have a voltmeter. This is voltmeter. All right, so connect. Just a minute. So we need to connect the ground with also, no? Then only it will work. So voltmeter, ammeter, and where is the ground? Is connected, but actually we have to connect across, right? Just a minute. So how can I do it? I can have draw a wire. Some problems are not working. Just a minute. Voltmeter. I'm connecting voltmeter. Just a minute. Sorry.
Isn't it supposed to be parallel?
Yeah. It should be parallel. I'm connecting in the parallel. And just a minute. So go to voltmeter, draw out, and ohm meter, test meter, ammeter. Is there voltmeter? These ohm meter, voltmeter. Then so it's just showing 0. Just a minute. Okay, so we can connect like this. Okay, connect here, connect here. Maybe okay, because it's not a proper connection, proper points. That's why it's not working. Just a minute. Let me just remove the value. You know that 4.3 millivolts. Okay, it should be 4.3 millivolts. So it should be connected to the proper connection. This is the proper connection, and this is the where's that? No, it should be yes now. But so why this is negative? Because the terminal is this one is positive, and we know that whenever current pass to a resistance, it basically know this is positive and negative, and bus the so voltmeter, this terminal should be here. So we can just reverse the polarity of this voltmeter by clicking here, I think. Swap the terminals. Let's see now. So now parallelly connected, and the value is 4.4. And how much I calculated? 4.43. Remember?
Yes.
Okay, 4.43. What was there? But now, how much is 4.4? But it is coming volts. It should be millivolts because 1K. Okay. So the calculation, yes, gonna be like this. Just see this one. So we calculated first, actually what we were calculating, we need to calculate the voltage. So we have to apply KVL, Kirchhoff voltage law. What we calculated earlier, we calculated that one current. For KVL, it should be, if we go, this is negative terminal, this is positive terminal, and here it will be positive, then it will be negative, and here is positive, negative. So when we apply this way, so we will say, V1 is equal to Vs minus, what is that? VB. It will not divide by, and resistance. If we will divide by resistance, it will be the current. So that you calculated 4.43, 4.3. That was actually current, but this will give you the voltage. So this is how much? 5 minus 0.7. It should be 4.3 volts. So now you can see here, it is 4.47 volts. So it is like it is mentioned that it will consume 0.7, but sometime 0.6 it works like that. So exactly it's what we consider always exactly 0.7, but sometime it took 0.6, 0.62 like that. So this is the voltage which are here. Even the value of the resistance sometimes is not exactly same value. So that's why this is the voltage, and the current will be like that, which we calculated. So current, yani we need to connect here in a series in order to find the current. So did you get the idea now?
Yes, it's clear now.
Yes.
Right? Yani, yes. Any question?
No, all clear.
All clear. So any diode is consuming some voltage itself. Otherwise, we are applying here 5 volts. So resistance must have 5 volt across it, but it is not having 5 volt. It is having 4.4. Yani around 0.6 something is consumed inside the diode, as I told you, because there is a barrier potential. And in a practical model, last lecture I told you, in order to conduct the diode, yani in order to be forward bias the diode, so it will be forward bias, it will take some voltage across it. This is the concept here. All right. Now, so if you have any question in your mind, just let me know so I can draw it, or you can try yourself now. So this is clear to you? A diode can work as a switch. Switch yani how a switch works. If I am saying it can work as a switch, switch means on and off. So on yani diode is in forward bias, yani it is conducting. Off means diode is in reverse bias, yani it is not conducting. This is the point, right? All right, now move to the application of the diode. Where do we use it? What is the use of it? So one of the most important application of a diode is a wave shaping circuit, or what we call rectifier circuits. So what is a rectifier circuit, girls? See, I'll show you here now. Okay, see, so this is AC wave, voltage. We know that one, AC, and its value is given here, maximum 5 volt. And frequency is 40 hertz. Okay, I'll show you its waveform first. So this is the waveform you can see here. If I do here, I will remove the one, I think. Yes, so this is AC source. Remove this one also. Top. remove plot. I want this one only. So one. Now only again coming. So it's showing input and output actually both. Okay, I want to see here what I am getting output. So I will also put this one here. Okay, so you see here what happening. I am applying here full cycle of the form. You can see here, right? Maybe I can just simulation speed can be down so that, or just stop. Yeah, stop is good. All right, see now. So I am applying this AC to my circuit, correct? This green AC. But what happening? We know that when this is above the zero, then only diode will conduct. Am I right, girls?
Yes.
All right. So diode is conducting during that time. See here. Understand? But what happened when the voltage are negative, diode will be in reverse bias, so it is not conducting at that time. So that's why this is clipped here. See this one? So this one, yani when it is in reverse bias, this during this negative cycle, half cycle, so no output there. Again, positive cycle comes here, this one. So it conducts, start conducting again. See this one? Right, again it reach here and voltage start building negative, so it is stop, then reverse bias. So this is forward bias, this is reverse bias, this is forward bias, this is reverse bias. Getting idea?
Yes.
So this is what we call half wave rectifier circuit. Yani this circuit can rectify only half wave. Any positive cycle is here and we remove the negative cycle. Understand the point? So this is called half wave rectifier. And what is a rectifier? Rectifier is basically circuit which convert AC into pulsating DC. If I put, do you remember capacitor also, girls? Capacitor?
Yes.
And I told you there is a special need of capacitor. You know, capacitor is actually useful to filter out the glitches here. Yani, if I connect a capacitor also here, so those are, we are getting here. Just a minute, see where we can have a capacitor. Capacitor. If I connect a capacitor here now, just a minute, I want to connect capacitor like this, and I will put. Then I will see the output also. Okay, now start this one. So this is how it is working, and I will see the voltage across the capacitor. We do one thing, remove this plot, remove the plot. So this is a single plot. Here the green one is the input, girls, and the output is across the capacitor actually here. Or I can right click, I can say add to the existing, just increase the simulation speed a little bit. Okay, so depend upon the value of this capacitor, this filtration will be there. Okay, so what I can do, I can increase the value of the capacitor, just make it 1000, and you will see the changes. Yani the output which we were getting there, it is gonna be more straight as like DC. Can you see the red line now? It is gonna be straight now.
Yes.
So it is becoming DC actually. Yani we apply AC and now we are getting here DC. And see what is the voltage across this diode. Right click and add to existing. So this yellow orange one is the voltage which is developing across this diode, but the red one is actual purified DC, and you know the DC, it is a straight line always. So this is so here this capacitor is working as a filter. So first this is a rectifier circuit, which is converting AC into pulsating DC. And it just clip the positive, any negative half, only positive cycle is there. Then the positive cycle which I am getting here, we pass through a filter, which is here a filter. And that filter is basically filtering the output here. You know, this is the concept here. So I can see one more thing. Okay, remove this orange one. And what is this? This one. Remove this one also. What is this? All right, now. So I want to see here. Okay, one and existing scope. So this is basically called rectifier circuit. Now we'll go to the theory and you will try to understand here. So what is a rectifier, what is the role of it, and all these things. So now move to there and start with that. So now we will discuss the application of the diode, where we can use it and what is the use of. The very first application is the half wave rectifier. So what is a rectifier? Rectifier are circuits that convert AC to DC. Actually, this is not a pure DC, so it is called pulsating DC. Okay. Then later on we apply filters, we call capacitive filters to make it pure. So special diodes called rectifier diodes are designed to handle the higher current requirement in these circuits basically. All right. So the half wave rectifier converts AC to pulsating DC by acting as a closed switch during the positive alternation. So girls, now you can understand easily when we apply this positive cycle appear across this diode, so it behaves like a closed switch. Okay, when it is closed, so this complete half wave reach to the load across the resistance and we can take it here. Okay, here we are ignoring the drop because we know that it will drop some 0.7 here, but just explaining the concept. So this positive cycle is developed by this AC source, so it will pass the positive. But what will happen during the negative? During the negative, the diode is gonna be in reverse bias. So when diode is in reverse bias, what will happen? This terminal will be negative, it means this terminal will be positive. So with more positive with respect to this one because it is connected to ground, which is 0, but this is now negative voltage we are developing across it. So what will happen during that time? The output is gonna be 0. See, this is the flat out. Understand? So this is the diode act as an open switch during the negative alternation. But during the positive alternation, it behaves like a closed switch. So whatever is here, it will reach to the load and we will be getting this one. So is it clear to all of you, the concept? Or any confusion, any doubt? Clear. Okay, so this is a half wave rectifier circuit, which why now you can also understand the name why it is half wave, because it is not rectifying the full wave. This is called full wave, na, completing this one, right? So it is only rectifying half only this portion. It is called half wave. Now very interesting thing, what if I want to rectify the negative half, which is also possible. Just go to this fall state and I can show you this thing as well. So what I can do for this one, if I reverse the diode, if I reverse the diode, at that time, what will happen? Half wave will be, negative will be rectified. For now, you can see what you are getting here. So I will do one thing, just remove this plot first so that you can see separate all the plots. Okay, so this is input, girls. Now this is the output which we are getting across this one. So in new scope. Okay, so this is input, girls. This is the output in new scope, you can see. So it is clear now. It is just filtering only positive cycle. The yellow one is here is the current actually, and another is the voltage across the resistance. Now if I reverse the polarity, I'm going to reverse the polarity. What do you think? What will happen?
It will be
If I reverse this,
only the negative value.
negative, yeah, negative wave will be filter out and positive will stop.
Yes.
So see now. Now you can see. Because now when the input voltage is negative, diode is in forward bias actually. When the input voltage is positive, diode is in reverse bias. So it is filtering the negative half cycle, not the positive this time. Clear? And hope you understand this duration, yani when positive input is there, that is that duration. All right. So clear concept. How can we also retrieve negative cycle? Just changing the direction of the diode. Okay. All right. So okay. So this is a half wave rectifier circuit now. So there are some numericals which you can solve it easily. So half wave rectifier. So this is the average value of the half wave rectifier circuit. And now girls, you know that what is the output of a half wave rectifier. You apply this. I'm writing input, right? And what is the output? This is input. And what is the output? Output is waveform. Clear? This is what? Input
And that's
to the half wave. And this is output, correct? All right. So now we want the average of the half wave rectified output. So we need average for this one, right? So the average is given by the formula VAVG VP out. Out means output voltage over pi. So here we will check what is the peak maximum value, okay, of output waveform, not the input, output waveform, okay, divided by pi to get the average value. Okay, so this question asks you calculate the average, so you can calculate this way. Okay, this is average. Next value, guys. Next thing is what? Peak inverse voltage. This is again interesting. Please focus. Peak inverse voltage. So what is the meaning of inverse voltage? Yani peak yani what? Maximum. Peak means maximum inverse voltage. So how much inverse voltage will appear across this diode? So we know that when the positive cycle is there, diode will be in forward bias and it will behave like a open, it will behave like a closed switch. Clear? During
Yes.
forward bias, it will be closed switch. But when we have negative cycle, negative, so diode will be open switch. Yani it will be in reverse bias. Yeah. So how much voltage will develop across this diode at that time when it is behaving like an open circuit? So that voltage will be the voltage, because you see this one is negative, this is negative, this is positive, this is positive. So the voltage which you are applying here, the same voltage is gonna be developed across this diode or not?
yes, it's
Yes, the same.
Correct? Yes, same. So the maximum value of the reverse voltage, but it is a reverse voltage basically, sometime designated as PIV, peak inverse voltage, occurs at the peak of each negative cycle. When it will occur? It will occur peak of each negative alternation of the input cycle when the diode is in reverse biased. Clear, girls? Right?
Yes.
So
Yeah, clear.
this is PIV. Yani if I am applying 5 volt here, so if I ask you how much is this one, so this is inverse voltage and it will be 5 volt. Yani diode must be able to handle this much of voltage. Understand? It must be able to understand this one. So if it cannot handle it, what will happen? It will break down. Do you remember? Because this is a reverse voltage. PIV is a reverse voltage. And if you remember yesterday, I was explaining you that this is the reverse direction and we keep on increasing, but there is a limit. If we cross this limit, what was that limit? Breakdown voltage, correct? So this is yani, -5 voltage is applying here. but we should know the breakdown voltage. So it should be at, you know, more than that. For example, if it is 10 volt and we are 5 volt is appearing across negative cycle, it is fine, yani. But for example, if it is 4 volts, yani breakdown voltage is 4 volt, and now we are developing across that minus 5 volts and it is minus 4 volt, what will happen? Diode will damage or not at that time? Breakdown voltage for the given diode which you are using is, it is now minus 4 volt. It means is that if you increase after minus 4, it will damage. And now if I connect the diode in a circuit where I am connecting 4 volt source, it means it is positive 4, negative 4 will be developed across this diode. So for example, now 5, for example, so 5 will appear. So what will be the PIV? PIV will be 5 volt. Peak inverse voltage will be 5 volt, but the breakdown voltage is given 4 only. So what will happen? Diode will damage or not? Because you are developing, you are giving more than the breakdown voltage to the diode now. So it will burn, it will damage. Clear? So it will be no longer working as a switch on off like that. Clear to all of you?
Yes, doctor.
All right. So yeah, it is about the breakdown and PIV voltage relation. Okay. This is what I want to explain. All right. See now. So this is the output of half wave rectifier circuit, which you can see, girls. Right. So what it clip here, it doesn't work during that time. So we have only 0 output at that time. But whenever positive is coming, we are giving this one. So now we have asked, for example, in the question, what is the average DC, right? So average DC, first we will calculate its peak value. We will divide by pi. Yeah, it is 100 over pi. And the answer is 31.8 volts. This is the average value. All right. Now, girls. So some different type of questions. Look, this one. Determine the peak output voltage. How much? Peak output voltage. And the average value of the output voltage of the rectifier. Indicate the input voltage. So we have given this one, and we are applying here. They are asking me here, how much will be the peak output voltage? So as I told you, girls, it is mentioned here 0.7 volt. Yani this will consume 0.7 volt. So how much will reach here? Simple. So I can say I apply 5 volt minus this much, because see, negative, positive, positive, negative, yani it is reverse polarity connected, so it will consume power. So yani 0.7 here, right? So we will be getting 4.3 volts at the output, yani here we will be getting V out 4.3. Okay, now they asked me to calculate the average. So yes, this is the voltage which I am getting. So if I draw the input waveform, girls, so my input waveform must be like this. Am I right? If I ask you draw, so you can draw also, right? So this is peak, VP out. And how much it is? We calculated 3. So average, so simple. V average is equal to 4.3 volt over pi, yani 1.35. So clear to all of you? Easy?
Yes, doctor.
All right. So this is about the half wave rectifier circuit. Yeah. Now, so next is what? Some more concept about the diode. I believe inshallah you can quickly give the answer. It's so easy now for you. So I am asking you here, determine whether each diode in the figure below is in forward bias or reverse bias. So girls, start one by one. Tell me the diode will be in forward bias or in reverse bias. Figure A first.
A will be reverse.
Reverse, okay. The logic, what is the logic behind?
Because the cathode is more positive than the anode.
Very good, because of the cathode. Okay, for cathode is this one, right? And it is 8 volt and it is 5. Your logic is absolutely correct because the cathode is more positive than the anode. Though it should be reverse. Yani anode should be more than the cathode, then only it will be in forward bias. So now it is in reverse bias. Clear to all of you? Any confusion? If no, move to next. This one here. Yeah. Okay, so Manar is saying it is in forward bias. Again, as per the logic of Manar, I believe it is negative 100 and it is 0 volts, right? It is 0 volt, which is positive, and it is 100 volts. So we know that anode must be more positive, but here it is 0, but it is minus 100. So now tell me, so it is gonna be simple forward bias because 0 is positive with this one, and if we just get the difference, so difference will be what? It should be that. So yani 100 volts. So anode is 100 volts positive with respect to cathode. It means it is gonna be forward bias. All right. Third one.
This is going to be forward.
This is going to be forward. Okay. So how it will be forward? We can say because this is 0 volt, correct? Yani cathode is connected to 0 volt. Okay. So here, yani this voltage is whatever voltage we are having here, girls, it is connected to this one. So we can calculate how much voltage is there. For example, if I say this is point A, so we can apply here current divider, voltage divider rule, and we can find some voltage here, even because it's a 30 volt, okay, 30 volts, and this is the largest resistance out of 1, 2, 3. Am I right? So maximum voltage will develop here, and definitely it will be more than 1 volts, correct or not?
Yes, correct.
Because we are applying 30 volts, so definitely it will be somewhere 15 or 16 volts, so which is more than the 0 volts. So anode is more positive. It means it is going to be in forward bias. All right, now here is your test. 6th, 8th, D1 here. So here maybe have confusion. How can you find out the trick? Reverse. Mariam saying forward. See, I'm saying here you will be having mixed relations. Look here, how can you find? So try to understand first. What you are connecting here? Ground actually. Or other than this, if you look at a different concept, positive, negative is connected and positive, both are connected here, right? If you look this side or this side, which is more dominating, positive or negative in terms of value?
The positive.
Positive because of 20 volts, right? So this is positive. If you go to this point, which is more dominating, positive or negative?
The positive.
Negative. No, this is a negative. Correct or not?
Yes, yes.
Okay, so yani you are connecting anode to the positive volt and you are connecting cathode to the negative volts. So khalas, it is going to be in forward bias. Even if you just look for the difference in this terminal, so 10 volt positive minus 10, just I'm giving you a hint, some idea, it's just trick. So 10 volt, right? And if you go here, 10 volt again, because there will be some drop here or here, but just like, some idea. So it is like that. So it is gonna be forward bias simply. All right. Is it clear now?
Yes, clear.
Right. So just some idea to understand whether it will be in forward bias or reverse bias. You can get it this way. Okay. So basically, what is the sense to understand these things? It's the sense is that you should be able to understand. You should be able to get the concept that anode should be more positive with respect to the cathode. Even if I give you this diode and I ask you, girls, I am connecting here 8 plus minus 8 volt, and now here I am connecting minus 10 volt. Now tell me, forward or reverse? Both are minus now. Both are minus now, but still, okay, still you are thinking it is in forward bias. Forward bias. The reason is anode is more positive with respect to cathode, but this is the concept. Clear na? To all of you?
And because it's closer to zero.
No. It's not about because of closer to zero. It's about it is more positive with respect to cathode.
Okay.
More positive because it's at -8. It is -10. Yani it is below more 2 volts. That's why conduct. It will conduct. Understand? You wanna see this concept? It's so simple. As I give you idea here, you can just draw some, circles, 2 batteries here, and then you can understand that one also. 2 batteries. All right. So here are 2 batteries. See these 2 batteries, right? So in 2 batteries, you can see, when we just run this one here, so you can see no current is flowing. Why? Because it is 5 volt. This is 5 volt. When I make it 4 volt, so see, it is working now. You can see easily. Diode is in forward bias, right? Current is moving. Now I'll do one thing. I'll make it negative now. Negative swapping, negative swapping. Still. Now I will make it a -8 volt as I said there. No, I will say bus 8 because I already reverse the polarity and make it 10 now. Same example which I just gave. See now. Conducting, current is flowing. Moving. The reason? Because it is -8, but this is -10. So anode is connected more positive terminal with respect to cathode. That's why. All right. So this is the concept of this one. All right. So I think we have done with this. Okay. Do you have this transformers understanding? Transformer. I think it is in physics also. So a formula for the binding ratios, winding. But I will finish this one slide only. Do you have idea of transformers studied in physics?
Yes.
So it is same. There is a one formula which is basically this is a different type of code they are telling here, and this is the transformer basically. So we have an input voltage here and we will be getting here. So sometime it increase the voltage, sometime it decrease the voltage. So we have a step up transformer, we have a step down transformer. So it's depend upon the number of turns. You see here the number of turns 1, 2, 3, 4. 1, 2, 3, 4. They are equal, right? So whatever I will apply, I will get here same voltage, right? So if we change the turn ratio, so accordingly we can say transformer is a step up or transformer is a step down. You see here. So now secondary, this is called secondary winding. This is called primary winding. So now secondary winding is having more turn. And you see here 4, it is greater than that one, double. So if I apply here 10, I will be getting here double voltage. So it is called step up transformer. The secondary voltage is greater than the primary voltage and n is greater than 1. Yani their ratio is greater than 1. Similarly, if step down, yani if the primary windings is greater than the secondary winding, so it will behave like a step down. Step down, yani I apply for 20 volt, I am getting only 10 volts. So I am stepping down the voltage. This is step up and step down. So here n is less than 1. So there is a formula, girls, which is that one. What is that? VP, yani primary voltage over secondary voltage is equal to primary winding, primary turn ratio over the second turn ratio. You know this one, right?
Yes, Doctor.
Yes.
Yeah, it was in physics. Yeah, I know that. So, but this is something which I want to tell you. Next, inshallah, we'll continue next week. It is one question about this one. So if it is like 4 and 1, it means here is 4:1 ratio. So they are asking calculate the secondary voltage. So here is the triggers because you have given here VRMS value and they are asking find the secondary. So what we know here N1 is 4, N2 is 1. It is something like that. Okay. So it will come 30 volts. So solution will be like that. So this is center transformer. We'll discuss next week, inshallah. Okay, this is full wave rectifier actually. So bus we stop here and inshallah continue next week. All right. So if you have any question, you can ask me or I will take quick attendance and leave you. But yeah, revise this one. This chapter is very interesting and I am expecting that you people will score good marks because it is gonna be now in the lab assessments next. And also we will be having a quiz, you know, the theory quiz, which will be from this chapter also. And this chapter will be a part of that quiz. So it's better you study during, it's so simple. Yani if you just revise it, it will not take more than a half hour or maximum 1 hour, but revise in during